Hello and welcome to the second video in the new Java 8 tutorial series that I am pushing up to the channel. In this video we're going to discuss the types of objects that are exposed in the Streams API, as well as how you might use them, and a little bit of an overview of what a stream actually is. So first, a stream can be thought of as a stateless, immutable, or a stateless iterator on an immutable object, sort of. If you provide a stream with some set of objects that it puts or collates together into some collection beneath the hood, then what you're going to end up with is a set of data and an iterator that can visit each element in that data set exactly once. If you want to visit any element more than once, you need to compose a function by using intermediate functions like map or flat map. What other options are here? You can peek, you can limit, which will give you the first size number of elements in that stream, and so on. So you take your intermediate operations. Other intermediate operations might be onClose, which give you a callback function, basically, or parallel, which returns a parallel version of that stream. So you have your intermediate functions, which you use to compose some sort of function to act on each element of the stream, and you have your terminating functions like reduce, or like collect, or for each. And by combining these two types of functions together, you can compose a long function to operate on a full set of data, and during every step, the data can be considered immutable. And so the assumption in Java is that you can thread these any way you want, unless you do, an ordered operation, you explicitly say so. Now, the two types of streams that are exposed in the API are object streams, which contain any object or any boxed primitive, also an object, and you can have a stream of whatever you want. The other type of stream that is exposed is a stream of primitives. So there's three types of streams of primitives. There are two that are absolutely necessary: long stream and double stream. Every primitive will fit into either a long or a double. Characters, integers, shorts, and ints will fit into a long. Floats and doubles will fit into a double. Now, the int stream is less necessary, but it's included because of its ubiquity in Java programming. There are just ints everywhere. Even though longs could be used, most of the time you're just generally working with ints. And the reason that only these three are included is opposed to having a different class for each of the primitive types, is to try to avoid the same kind of class explosion that has been seen over time in other Java APIs. The other type of object that is exposed are collectors. So a collector is an input to a collect terminating function, and what it does is take the stream that it is collecting and collate all the values in that stream into a single object somehow. The utility of collectors is very broad. You can collect a stream into an array or some collection. You can use a collector as a reduction function to collect them into a box integer or something, or to collect a set of strings here into a single string, as we do with the reduce there. And the collectors class is a utility class that contains a bunch of different common collectors. Let me go ahead and take a look at one of these. We don't need all of this. We can actually just use collect, and then we'll use the collector joining. Now, as it is, we'll just get it all as one word. We need to pass the joining character to the collector, and then we run it. We'll go ahead and get our hello world back again in, I would say, not only a terser way, but also a much more readable way. Now, we'll go ahead and use a stream here, a couple streams here, to express the second simplest program that gets tossed around here. We're going to sum the first set of 10 integers. So in order to get the first 10 integers, int stream rather, we'll take our int stream and we'll take range closed, because we are going to want 0 through 10 inclusive. Range would, if we did this, would just give us 0 through 9 inclusive. And we're going to want to assign this to our integer out. Of course, since we're doing that, we'll go ahead and comment those 2 lines away. So now what do we do? Well, we sum. Done. Now, it's a little cheaty because not all functions are going to be so simple as that, so we should probably learn how the sum actually works. Well, a sum is just a special reduction operation, right? So we go ahead and use our identity integer of 0, and we'd use integer ::sum to get the method reference for the sum function for integers, and then we go. Easy, we get 55 once again. There are other ways to go about this. We could explicitly state our lambda function. So we have our identity of 0, and then we have an int by consumer. So it'll have 2 inputs, and it consumes integers. And we want it to return I plus j. What's up? I don't know why it's complaining about that in the first place. Okay, we can just do it like that. If I wanted to do it more explicit, if I wanted to do it in the standard way you might do it if you have more options, then we can return the full I plus j like that. And you might want to do some other operations like I plus plus minus minus, or maybe I have to okay, actually that's not never mind. That wouldn't be legal inside of a lambda operation. But any other functions you want to put up here, this is sort of the way that you would make it look like a for loop if you wanted to use it in that manner. One important thing to go ahead and show that this works. One important thing to keep in mind is that you can't modify primitives or values inside of a lambda function inside of a stream. So if I were to set this up more like a traditional stream, or more like a traditional for loop rather, we would have this. We'd have int out equals 0. And instead of reduce here, we would have a for each function. We'd take a single int consumer, I, and then we do a thing with it. Out plus equals I. This is not valid. And it will tell us why it's not valid. Local variables referenced from a lambda expression must be final or effectively final. And what this means is, since we're trying to change the value of out, which is outside of the stream and not a value that would be passed directly into the lambda function, or would be passed to the lambda function from the function that the lambda function is called from, it's not available for the lambda function to act on. So what you need to do, and this will let us do it automatically, is turn out into a single element array, and the first element of that array is available for access. The object itself isn't changing, the integer array, just the integers inside of it, which is entirely valid, if a little bit clumsy. But of course, I would say that the better way to go about this would just be int out equals int stream dot range closed, whoops, 0, 10 sum. Nice and terse, simple and easy to get, very easy. And very clear and readable as well, which is one of the big benefits of Java 8. So that is sort of an overview of how you might use streams in a more day-to-day context. You replace your for loops with them if they're non-side affecting, or if the side effects are predictable enough that you can manage it. And in the next video, we're going to discuss lambdas, followed by method references, and sort of what is and isn't valid when you're using each of these new methods that are allowed in Java 8, or available in Java 8 rather. And from there, we'll take streams, lambdas, and method references and start doing some refactoring to sort of help get a feel for how streams can be used in a more day-to-day context. Thank you. I've been Naifen, and I'll see you next time.